So hi everybody, my name is Victor Stinner. I'm a Python core developer since 2010. Currently I'm working for Red Hat on Python on OpenStack, and I'm a very happy user of Fedora on Vim. I decided to organize my talk in four parts, and the 4 seasons. So let's start with autumn. At the beginning, the Python 3 project was known as Python 3000, and then in 2006, a PEP was written by Guido van Rossum to fix the Python warts. Python warts are a design issue of Python 2. The thing is that more and more people started to complain about design issue of Python 2, and someone started a list of all those warts. So it was decided to try to fix them, and you need to modify the language to be able to fix them. To give you some example, in Python 2 you have two kinds of numbers. You have the small integer, but you have also the large integer. So depending on the value, depending on the type, you may get a small or large integer. And it's not really convenient because when you would like to test the type of a variable, you have to check if it's a small or large. And during the development of the Python 2 cycle, we introduced a new kind of class called the new class, and you have to explicitly inherit from the object type. But if you don't do that, you still get the old class, and some new features like properties are not working properly. The integer division, the issue is that when you are new to programming, when you divide two integers and get an integer, it can be surprising because people are used to calculator, which give you a floating point number. So it was also decided to change that to get a float if you divide two integers, but you still have the double slash operator to get an integer. For the Unicode, in short, it works pretty well in Python 2 if your whole application is designed for Unicode. If all your inputs are Unicode, if all your inputs are Unicode, everything is fine. It's also fine if you are only using bytes. But if you are, in some part of your application, you are using bytes, in some other you are using Unicode, it depends on the content of the text. And for example, when you get a name with a diacritic on a single letter, it's enough to get an hard error. So it was also decided to try to fix that. The comparison in Python 2. In Python 2, the principle is that the comparison never fails. And if you cannot compare two objects, what Python does is to take the name of the type. For example, when you compare an integer on a string, you get the string int and the string str, and you compare the string to order the two variables. And this result can be surprising, and we also want to fix that. The last item is imports in Python 2. By default, if you have a module with the same name of a module of the standard library, you get a conflict. And that's not really convenient. It's very common for newcomers to make this mistake. So we decided to not use relative import by default, but use absolute import. From the beginning, we already know that there is a high risk of breaking everything. So to reduce the risk, what we decided to do is not to break everything, but only focus on acknowledge warts to limit the number of changes. We also decided to have an open community process. In practice, it was the Python 3000 mailing list and the PEP with all number starting at 3000. And it was also decided to not re-implement the interpreter from scratch to try to reduce the risk of backward compatible changes. And from the beginning, we also decided to plan the end of life for Python 2 to make sure that The users are aware that the migration has an end, and we would like to push people to Python 3. And in 2008, the holy grail, Python 2, finally we got it. At the beginning, the migration plan to port an application from Python 2 for Python 3 was quite simple. We provided a tool called 2 to 3, and the idea is that you run it once on your code base, and you're done. Everything is converted automatically. But maybe if we are still discussing Python 3 today, maybe it didn't go as well as I expected. In practice, the thing is that you cannot drop Python 2 supports because when you are the author of a module, you don't want to lose Python 2 users because when Python 3 was released, we didn't get Python 3, for example, on Linux. You had to wait a few years to get Python 3 on all Linux distribution. And another issue with the migration is that when you would like to port an application to Python 3, you first have to make sure that all dependencies of your code are compatible with Python 3. If a single dependency is not compatible, you are not able to start the migration. And last but not least, Python 2.7 was heavily used in production. That was an unexpected fact because Python 2 was still a young language, and we didn't know that we had so many users. And having large code base on production means that it takes much more time to do the conversion. To explain you another issue with the migration, let me introduce you the technical debt. Imagine that you are discussing with your manager, and your manager is asking, why should I let you work on Python 3 supports as a developer for all these new cool Python 3 features? Okay, but can we use all these features? Well, since we still have to support Python 2, in practice, no. Because you cannot use Python 3 features if they are not available on Python 3 features on Python 2, so the migration doesn't add any value directly. When you port an application to Python 3, you get a Python 3 version and a Python 2 version. So some people decided to use two branches in their source control management, like Git. But some projects decided to be forked to have two different repositories. In some cases, the migration was done upstream. For example, the DNS Python was forked as a new project called DNS Python 3. In some cases, the fork was done by the community because the company behind the project didn't see the value of spending time on the thing called technical debt. In this case, the community forked the project. For example, the pill was forked as pillow. And in the worst case, the upstream doesn't read bug report anymore, doesn't review pull requests. The project is dead. And one good example is that I'm working on OpenStack. On OpenStack, we like to use MySQL database. And to connect to the database, you are using the MySQL Python driver, but the maintainer stopped to do anything on the project. And it was a real blocker for us because it was used by all components in OpenStack. So someone forked the project as a new name, as a project MySQL client. It's not only a Python 3 port, but also it has new features, it has less bug. But we still have the issue of packaging because Linux distribution didn't know what is the best upstream because the fork is still maintained, but maybe the old one will be maintained again. So that was an issue. And when you would like to write a single code base for Python 2 and Python 3, you have other kind of issues. For example, when Python 3.0 was released, the stable version of Python 2 was still Python 2.6. And using this version, you still have to modify a lot of code to be compatible with Python 3. For example, you can use the 6 module, but you have to annotate string using 6.u prefix to call a method. Because if you use a u prefix on Python 3.0, you get a hard syntax error. And you get this error until Python 3.2. It was changed in 3.3. To use new Python 3 features, like the new unit test module, you have to use backports. And Python 2.6 requires a lot of backports. So at the beginning, it was quite complicated to write a single code base. And after the spring comes the cold winter. And the winter starts with the Python 3 wall of shame. In 2011, someone created this website, but the intent was not to blame people. The intent was to motivate people to port their code to Python 3. But obviously, when the website was created, only very few packages, like 9%, were compatible with Python 3. This is a list of the 200 most popular modules on mypy. And in Python, we had 3 big projects. I identify this one. There is a Twisted, which is a framework to write network application, not only client application, but also servers. There is Mercurial, which is a source control management to track your source code as, for example, Git. There is also the very famous Django web framework, which contains an ORM, templating engine, and everything that you need to build your own blog or any kind of application. But all this application had issue to be ported to Python 3. In the case of Twisted on Mercurial, the issue is that on network, you don't get Unicode. On network, at the wire level, you only get bytes. And because of that, the Twisted use bytes in many places. And in Python 3, the native type for string is Unicode. It means that using bytes require more time, more code. And for the Mercurial case, it's not only for the file content is managed as bytes, but also the file name. So you get bytes everywhere, and it was a little bit difficult for this project to be ported to Python 3. For the case of Django, when Python 3 was released, the Unicode support was still a work in progress, and it took time to just manage correctly Unicode. Because all the issue that I described, we started to see more and more Python 3 trolls. It's the French people here. The Python 3 was seen as doesn't bring anything new, because since you still have to support Python 2, you cannot use new features, and moreover, until Python 3.3, we had no killer feature, we had no super cool feature to really motivate people. And another aspect of this role is that they consider that using bytes is a most obvious choice, because when you use bytes for text, you get bytes in, bytes out, and you never take care of the encoding. You never take care of encoding errors. And even if you have 2 different content of 2 different encodings, it just works. Maybe in some cases you get mojibake, but who cares? And because the migration took a lot of time, some people started to consider that, well, maybe, because Python 2 is still alive, maybe we can just continue the Python 2 development. So an idea started to occur. It's to create a new version of Python 2, which will be the Python 3.8. And in 2014, there was an article on Linux Weekly News called Debating Transitional Python 2.8. They were concerned that Python 3 would never take off because, according to them, the Python 3 only represented under 2% of packages. But to make it very obvious, what we did, the core developer on the Python community, is to make it very clear and obvious that we will not do a Python 2.8. So in 2011, we created a PEP 404, the PEP not found, which is a Python 2.8 on-release schedule to make it very clear that there is no Python 2.8. In 2013, we got 80% of the top 50 projects supporting Python 3. And in 2014, in my opinion, this is one of the best choices that we did for the Python 3 transition. We extended the support of Python 2, because at the beginning it was only 5 years, and we doubled this time to 10 years until 2020. It was an announcement made by Guido van Rossum at Pycon US. It was decided to make it very clear that we care of Python 2 users. We don't want to blame people. We don't want to force people to move to Python 3 right now. We are giving you more time, and we understand that when you have a large code base, it takes time to port everything. And after the cold winter comes fresh air of the spring with flowers. And the very good news is that the first problem has been solved. So what is the first problem of Python? It was to install dependencies. Because when you wanted to install a dependency, the answer was, okay, you have to install setuptools. But I don't have a setup tool, so how can I install setuptools? And it was a little bit tricky to fix all these issues and at the end to be able to install something. So in 2011, we released, pip 1.0 has been released. And in 2014, Python 2.7.9 and Python 3.4 now includes ensurepip. It's not pip itself, it's an installer for pip. So you don't have to care how to install pip, it's already in the language. And thanks to that, slowly pip became the de facto installer. You don't have to ask what is the best way to install dependencies, the answer is just pip. And Linux distribution also started to include pip. And to port application to Python 3, instead of forcing people to drop Python 2 supports, we started to see a new approach, which is add Python 3 supports. Today, it seems obvious to work like that, but 10 years ago, it wasn't that obvious because we didn't know all issues that people had to port application. We didn't have the tooling. We didn't. It took time to come to this approach. But the main advantage of this approach is that instead of migrating your application at once from 2 to 3, you can do it incrementally by small changes. To do this migration, you have two tools. You have modernize and Sixer. Sixer was written by me. And it's a good example of the kind of issue that you have in real life. Because I'm working on the OpenStack project, and in OpenStack, if you use modernize, you get a giant change set, and this change set will get in conflict very shortly because the code evolves very frequently. So you cannot manipulate such huge changes. To do that, you have to generate smaller changes. So what I did is to write a tool to apply a single operation. For example, just add parentheses to the print statement. And by doing that, you get a much shorter change. It's easier to get them reviewed because they apply a single change, so it's much faster to read them. And thanks to the CI and the unit test, you make sure that this tiny change doesn't regress. For large code bases, you may need to write new tests because Python 3 means a lot of changes, and some companies are very good to write code fast, but not to write tests. And nobody wants to get regression, so you may have to first write tests before starting to migrate your code to Python 3. And Dropbox is also trying something different. They are annotating the type of a function parameter and a function return type using a new module called typing. And thanks to this annotation, they are able to run a static analysis with the tool called mypy. This is good already for Python 2, but it's very useful to port your code to Python 3. So not only we get better tools, but we also made other changes in Python directly. For example, Python 3.3 reintroduced the U prefix for the string, which avoids to use the 6.u function on each string. Python 3.5 added back the bytes formatting, which is very useful for Twisted and Mercurial. And on the Python 2 side, we added more Python 3 warnings. This means that you don't have to port directly your application to Python 3. You can just enable this warning and be able to identify which part of the code should be ported. And other bridges between Python 2 and Python 3 are backports from Python 3 to Python 2 to be able to use new Python 3 features. And after the cold winter and the spring comes summertime. To come back to the wall of shame, we only had 9% of the project supporting Python 3, and today we are done. We ported almost all projects, 95%. In fact, it's not really all these projects, not all 200 most popular projects, because in this list you have many projects which are no longer supported or replaced by something else. So we don't have to port everything. Another very good news is that Python 3 is much faster. So this is a graphic to compare Python 2 and Python 3. The orange line is Python 2, and anything lower means that Python 3 is faster. And on these cases, you can see that Python 3 is much faster. To explain it differently, the company Instagram is fully based on Python. Their code base is based on the Django, and they ported all their application to Python 3. And thanks to that, they saved CPU by 12% and memory by 30%. To explain you the advantage of Python 3, you have to know that we have a long list of Python 2 bugs because more and more people are using Python 2, and we know that there are bugs. But slowly, we cannot fix some kind of bug because of the thing called backward compatibility. For example, Unicode supports, even if we could make some changes to enhance Unicode, we don't want to do that just to not break user application. About security, there is a vulnerability in dictionary type, which is a denial of service if you inject some well-prepared string to get the worst complexity, and the application becomes much slower. In Python 3, we have a fix for that, but we cannot enable it by default because it changes the order of the dictionary and the sets. So in Python 2, even if we fix this vulnerability, it's not enabled by default. And you have also very complex issue. For example, subprocess is not thread safe. The recursive lock is not senior safe, and the internal clock are not monotonic. It's not easy to understand this issue and not easy to reproduce this issue because in most cases they are race condition. But you have to know that we fix them in Python 3. For example, in Python 3.3, I added a new monotonic clock, and I also modified all internals of Python to use monotonic. It means that when you change time between winter time and summertime, your Python 2 application may be stuck for 1 hour or just explode. And in Python 3, it just works. In Python 3.4, I modified the file descriptor to make them non-inheritable. It means that when you spawn a new process, you don't inherit a sensitive file like passwords or connection to a database or anything else. You don't inherit them any longer by default. And in Python 3.5, we retry the system call which are interrupted by senior. So you don't have to modify your application to retry manually. It's just done by the language. If you compare Python 2 and Python 3.7, we had not less than 21 new modules. For example, there is async IO, which is very famous for asynchronous programming. There is a new enum module, the pastlib, which is very popular to manipulate file names. The unit test.mock, which is very useful to write unit tests. So you have a lot of modules that you don't have to install. It's already part of the language. And what I wanted to show you also is that it's not only the thing around the language, it's the core of the Python, the language itself also evolved to add new features. For example, in Python 3.6, so the current stable version, we added f-string. It's a new way for format string, and in my opinion, it's the shortest way to format string, and it's the most obvious because it's very easy to read it. Not only you can get the content of a variable, but you can also call methods. You can also write any Python expression. We spend a lot of time to modify the language for asynchronous programming, because even if in Python 2 you can do asynchronous programming, but you have to use callback, which is very painful to debug. You can use yield, which is not really convenient. So the first change was to add a yield from, which is a way to delegate a generator to another generator. And later we added async and await keywords, and these keywords makes the asynchronous programming much more straightforward, because it's very obvious that await is waiting for something, and that your code is interrupted at this place until you get, for example, data from a socket. More recently, we added the yield in asynchronous function in coroutines, so you are able to implement generators, asynchronous generators, and also async for and await in list comprehensions means that you are able to build lists in asynchronous way. You have more new features in Python 3. For example, the keyword only is a way to force users to pass the name of the parameter to avoid bugs in the code. The print statement was replaced by a print function, which gets keyword arguments like file or end for the end of line. You have the star to unpack a list. You can use it in very different ways, and basically you can use it anywhere in Python 3. You can use it to build a list, and the double star can be used to build a dictionary from a different dictionary. And Something very stupid but very useful is that when you write a long number with a lot of zeros, like 1 million, you can now add an underscore in the number, and thanks to that, it's much more easier to group digits to make them much more easy to read. You can also add annotation to the type. Again, this is part of the whole project to run static analysis of the types. In Context Manager, you can add multiple statements. Again, we get the bytes formatting. And for the new operator, the @ operator, this one is very useful in NumPy because in Python 2, you have to use a dot function, but you have to write your expression differently. It's non-obvious if you come from if you write it by hand, it's different. And using this infix operator is much more obvious. So Python 3 is much faster. We ported most applications. So the question is now, maybe it's time to bury Python 2. In practice, we already started to do that because if you look at the Fedora released 3 years ago and the Ubuntu released last year, there is no Python 2 in the base system. It means that when you install Fedora on Ubuntu or Ubuntu and you type Python or Python 2, you get an error because it's not part of the system. But obviously, if you still get a Python 2 only application, you will pull the Python 2 dependency. There is also the Python 3 statement, which is a global timeline for all scientific projects to give a timeline when Python 3 support was added in each project, but also when Python 2 support will be dropped. So you have a very clear timeline for your own use case. Python clock is a simple countdown until 2020. And for your information, it will be the 1st of January of 2020. And last year, we started to see 2 big projects which dropped Python 2 support. It's Django, which is, in my opinion, it's very important for the Python community because Django is a strong project, a very popular one. And Django 2 and IPython 6 are now Python 3 only. I'm working for Red Hat, so to give you the status of Red Hat, we just announced that Python 2 is now deprecated and will be replaced by Python 3 in the next Red Hat Enterprise Linux major release. In the meantime, you can get software collections. Software collection is just a different repository that you can enable. And by doing that, you get Python 3.6, the latest stable version. You get it on RHEL and CentOS 7. And for RHEL 6 and CentOS 6, you get Python 3.5. You just have to know that these software collections are supported, but their support is much shorter because the operating system is supported by 10 years or up to 15 years if you pay more. This software collection are only supported 3 years. It means, for example, that Python 2 has been released because it was released a few years ago. And just to finish, I would like to open a question. I show you that it took time to port everything to Python 3, so maybe we can take some ideas from Daniel Esposti's talk. The talk made 2 days ago, called Evolution or Stagnation of Programming Languages. Daniel explained that JavaScript is much more successful to introduce language evolution, but don't break the backward compatibility. JavaScript has a different approach. In JavaScript world, the virtual machine is usually the browser, and we don't control the browser. So the thing is that you have to support all the version of JavaScript. You have to support all browsers. So from the beginning, they knew that they really have to support the backward compatibility. And what they did is to spend a lot of time on the thing called transpiling to convert a new JavaScript to old JavaScript using tools like Babel and Polyfill. And thanks to that, you are able to use the newest version of JavaScript right now, and you don't have to wait 10 years until everybody is using a new browser. Thank you.
Thank you very much.
Okay, now more seriously, Python 4. We are aware that we made a lot of mistakes in Python 3, and we learned from our mistake, and we will not break the word again. We know that we only had a single bullet, and Python 4 will just follow the same migration process from any other changes. So it means that we deprecate a function, and we get at least 2 cycles to remove something. So Python 4 will be just the version following the latest Python 3 release. Don't worry. Do you have any question?
Thank you. Any question? Come on.
So everybody ported the code to Python 3?
No one? Okay. Oh.
Did you have a systematic approach in speeding up things in Python 3? Or they just came out of
the
part of
optimization?
Yes, did just came out of some new semantics, or they are
optimization are not coming for free. The first release of Python 2 was much slower than Python 2. And we spend a lot of time to implement not a single kind of optimization, but it's more a large range of optimization. And when you combine all these things all together, it means that even if you get the new Python 3 features, it's still faster than Python 2. Because, for example, in Python 2, when you call the map function, you get directly a list. It's very efficient. And in Python 3, you get a generator, and by doing that, it's faster by design. And even if it's a generator, the thing is that we optimize it a lot, and today it's much faster. And the good news is that the next version of Python 3 is already faster than the previous version of Python 3. Another question?
Okay, thanks for the talk. Can you explain a little bit what the next new cool features will be for, I don't know, Python 4? I'm not sure if this is really a joke, or I didn't get the latest to the 4.0 transition explanation, and what these release cycles are. I mean, what is the idea between in moving fast, and how fast is this going to be from 3.8, 3.9? I don't know.
Okay, but the release cycle, currently the cycle is almost 18 months, so it's 1.5 years between each release. It's not a strict cycle, it's decided by each release manager. And some people wanted to get the changes faster, so there was a PEP to get shorter cycle, but it was not accepted. And about new features, we don't have a long-term plan, because we are not a company, we are all volunteers. So it depends on the motivation of each developer, depending on the use case of each developer. But the next version will be released in 2 months or 3 months, And you can already see what's new in Python 3.7. And this list is almost complete because currently we are in the freeze time. We are not allowed to add new features. And I don't recall the full list of features, but you have many of them. You can go to the website of the developer version of the documentation to get it. Yes?
I've got a question related to the microcode. Were there any changes between 2.7 and 3.x in as far as microcode is concerned? And if I get a 2.7 function in 2.7 and I list the microcode, would it be the same in 3.x or it's
the microcode, do you mean the bytecode?
Yeah.
The bytecode is very different from Python 2 to Python 3. We added a new opcode for optimization. For example, the next release of Python 3 has a new load method and call method, which replace 2 or 3 bytecode by a single one. So it's much faster to call a method. I don't recall all the detail, but there are other changes like that during the Python 3 cycle. And in Python 3.6, we changed completely the format on disk, the binary format of microcode, because previously it was 1 byte for operation with no arguments, and 3 bytes for operation with an argument. And for optimization, we make sure that now everything is always 2 bytes. And thanks to that, we avoid some tests. We can make the code much more efficient. So we change also the binary code.
Okay, the last one.
We migrated from Python 2 to Python 3 and completely rewrote our backend. Now we are using microservices with async.io. And async.io changed a lot from 3.4 to 3.5. New syntax, and now there is pathlib, which is more or less compatible. Do you know if there is some new groundbreaking changes or backward breaking changes for the whole async.io concept in the next releases?
I was not really enjoy the idea of putting async.io directly in the standard library, because the project was really young. At the beginning it was a design, it was quickly implemented, and we found a lot of issues when people started to use it. So in some cases, to fix some design issue, we had to modify async.io and to introduce backward incompatible changes. For example, I know that cancellation is a very complex topic in asynchronous programming, and there is still an ongoing project to fix some corner cases in async.io. So everybody wants to get a stable library, but we had to make some changes for that. And about the syntax from yield from to async and await, what I heard is that Facebook decided to migrate directly to 3.5 just for the syntax, because according to them, it's much more obvious to read the code using the new keywords. So I know that it's painful to have to modify your code regularly, but it's also a power of Python 3 to be able to move faster than Python 2.
Thank you, Victor.
Thank you.